Partial fraction decomposition, so a bit boring, but we set out to do all of them, so let's get on with it. All right, now to start, we're gonna say that the integrand there, which is this here, is equal to some constant a over x plus some other constant b over x plus 1, and then plus cx plus d, some linear, over x squared minus x plus 1. So yes, I'm writing this. I am claiming that x plus 1 times x squared minus x plus 1 is how you factor x cubed plus 1, which is correct. You should know that from algebra, sum of cubes factoring, right? Okay. Now, to compare the left side easily with the right side, we should get common denominators on the right side, so that we just have to compare the numerators. So that amounts to, well, multiplying a by this times that, right? And so that's a times x cubed plus 1, and then it's going to be plus, let me scoot this closer actually, a times x cubed plus 1, and then plus, I'm going to have to skip on to the other board. So for b, we have to multiply by this here, x, and this quadratic. So it's going to be bx times x squared minus x plus 1, and then plus cx plus d is going to be multiplied by, what's cx plus d going to be multiplied by? This is going to be multiplied by x times x plus 1, so that's x squared plus x. Now, this here would have a common denominator with this, or it would have the same denominator as this here, right? Okay. And so we just say this here, which is going to be the numerator of the right of the equal sign, will have to equal the numerator of this left-hand side, now that they have the same denominators. And so that would be 2x cubed minus 1, right? Okay, now to solve for a, b, c, and d, we have two options. One is to the right of the equal sign to multiply what we have to multiply and combine like terms, and then compare coefficients of the right side with coefficients of the left side, where the coefficient of x squared in here is 0 and the coefficient of x is 0, and so on. So you could create a system of equations that way. But I have a better idea, which is, since this equation has to hold true for all x's, we can strategically pick x's so as to simplify this equation and allow us to get to a, b, c, and d quicker. For example, if we let x equals 0, look at what happens. Here I'm going to get -1, right? X equals 0 implies to the left of the equal sign I get -1. To the right of the equal sign I get a times 1, so that's a, plus, and then x is 0, so this is b times 0, and so this whole thing is going to be 0, and then x is 0, so 0 plus 0 times that is going to be 0, so I immediately get to -1 is equal to a. Nice. So a is -1. Okay? So can we similarly pick other x's to get us to the other constants quickly? Yes. Not as fast, other than b. We could get to b quickly, and it's to let x equal -1 that allows us to get to b quickly. When x is -1, notice that here we get 2 times -1 cubed, which is -2, minus 1, which is -3, right? So -3 equals, and then here we get -1 plus 1 times a, so that's 0 times a, so that's 0. And then here we get -b, right? -b, and then when we plug in -1 in here, we get 1 plus 1 plus 1, so that's actually -3b, right? And then when we plug in -1 here, we get 1 minus 1, which is 0, so this whole thing is 0. So -3 is equal to -3b, meaning b is equal to 1. Okay, cool. B is equal to 1. Nice. Now, we know a is -1 and b is 1. So that means that I can replace a here with -1, which amounts to putting a -x cubed and then -1 in this part, right? And then we know that b is equal to 1. So b is equal to 1, and this is not written well. b is equal to 1. So here I could replace that with a 1. And then if I multiply this, I get x cubed minus x squared, and then plus x, right? Okay, nice. Now what I could do is add 1 to both sides. That means I could get rid of this and get rid of that. Add x cubed to both sides. Actually, I don't have to do that. I can cancel this minus x cubed with this positive x cubed. So right now on the left side is just and I'm getting rid of this, right? But I don't want to accidentally get rid of that. So I have 2x cubed, right? So 2x cubed is equal to that, is all we have. Nice. So if we add x squared and subtract x from both sides of this equation, we get 2x cubed plus x squared minus x is equal to this here, right? Now, in this part, from here, I'm going to take out an x. So I take out an x, meaning I write x times x plus 1, right? This here is that. And then I have times cx plus d, right? Okay, now if I divide both sides of this by x, I could get rid of this x here, and then I could turn that into a 1, right? I could get rid of the square there, and then I could turn this into a square. Oh, how nice, because here we have two binomials, which if we multiply them are going to turn into a quadratic. So we have 2x squared plus x minus 1 is equal to, actually I need space, sorry, 2x squared plus x minus 1 is equal to, okay, if we FOIL here, we get cx squared, and then plus dx, and then plus cx, and then plus d. From this, we see that first, because we have no choice on the coefficient of x squared, there's only one coefficient here and one coefficient here. It must mean that c is equal to 2. And then the middle coefficient, 1, right, 1 will have to equal c plus d. Knowing that c is 2, that means that 1 is equal to 2 plus d, meaning negative 1 is equal to d. All right, negative 1 is equal to d. Well, this constant term is alone just like d, so d would have had to been negative 1 anyway. So c is equal to 2, and then d is equal to negative 1. Right? Okay, cool. So that means now we come here and erase, and we don't need this anymore either. Okay, maybe need the space. Right? Okay, so that means that the given integral, this with the dx here, is the same as this with the dx. Okay, right? But now that we know a, b, c, and d are ABCs, we've got negative 1 over x dx plus integral, and then b is 1 over x plus 1 dx, and then plus integral, and this is c is 2, so 2x minus 1 over x squared minus x plus 1 dx. Right? Okay, cool. Now this here is just negative natural log of x. Right? This here. And then this here is natural log of x plus 1. Right? And this here, if you let u equal x squared minus x plus 1, notice that du is exactly 2x minus 1 dx. So this would be du over u, which would have integral natural log of u, where u is that. So we see that the antiderivative of this is just plus the natural log of x squared minus x plus 1. And we can write our plus c out here. So this is our final answer, only we can use log rules to combine this, right? The log product rule would allow us to write this as the natural log of x plus 1 times x squared minus x plus 1, which is x cubed plus 1, right? And then this here is this minus ln of x is the same as ln of x to the negative 1, which is the same as ln of 1 over x. And so again, using the product rule with this and this, right, because we'd have a plus sign between them, we'd have ln of 1 over x plus that. And so combining, we see that our final answer is actually the natural log of x cubed plus 1 over x, and then plus c. Yeah? Okay, cool. All right, that's it for 19, and 20 will wrap it up. Hope you enjoyed this. Keep watching. Take care.